So this is 5-6, hopefully a moderately short section, hopefully not that challenging of a section. I don't even think you need a calculator to do this section, which makes it kind of nice. There's a video online that explains the solution process to these problems probably better than I can. So I'll play the video now, and after the video's done, I'll work all the problems. But maybe after watching the video, you'll be inspired enough to do all the problems by yourself, which would be absolutely fantastic. But we'll give this a watch and decide how much of my work you need to watch.
And remember, whenever you solve a quadratic or a second degree equation, I guess this is an inequality, I should use the word equation, it's tempting to sometimes do it the same way you do a linear equation, kind of getting all the x terms on one side and all the constants on the other. But it never works because you actually have an x term and then you have an x squared term. So you actually want to get it kind of what I would call the, I don't know if it's actually called this, the standard form, where you actually have all the terms on one side and then a zero on the other side, and you can either factor it or use a quadratic equation. So let's do that. Well, this is pretty easy.
Okay, so now that you're experts at this, I can just let you do all the problems, I guess. I'll do all these problems with a little more detail than was shown in the video, just in case some of the stuff he did kind of in his head, kind of hand waving, is a little tricky for you. All the problems in this section are already set less than or greater than 0, so I'm not going to need to manipulate any of the problems to start. The first few problems are all quadratic equations or problems with squares, and in these problems the first step we're going to do is we're going to factor. And the factoring is all really nice in this section. This factors into x plus 6 times x minus 1 is less than 0. So for every one of these problems, the first thing I'm going to do is I'm going to factor, at least the ones that have factoring, the non-fraction ones. And then I'm going to create two scenarios. Because I want to multiply these two factors and get a negative, they have to have different signs in order to multiply two different factors and get a negative. So my scenarios here would be having one of the factors positive and the other one negative. That's my one scenario. The other scenario is to have the first one negative and the second one positive. The only way I can multiply two factors and get something that's less than 0, which is negative, is if they have opposite signs. And the two scenarios that create that are this one being positive, that one being negative, or this one being negative, that one being positive. And that's what this says. This says the first one is positive, the second one is negative. Multiply a positive times a negative, you get a negative. This one says the first factor is negative, the second factor is positive. If you multiply negative times a positive, you get a positive. I'm going to solve these just like they did in the video now. I'm going to minus 6 from both sides and get x is greater than negative 6. I'm going to add 1 to both sides and get x is less than 1. To figure out the solution to this, I need to find where any number that is, I need to find where numbers are both less than greater than negative 6 and less than 1. To do this, I create a number line, put the numbers of interest on my number line, which are negative 6 and negative 1. I'm going to graph each inequality. I'm going to use open circles because I don't have an or equal to. I'm going to put an open circle on the negative 6, and greater than I go to the right of the 6. So I made my open circle on my 6, went to the right of 6. For the x is less than 1, I'm going to write an open circle on the 1 and go to the left of 1 because less than is to the left. Any place where I have both lines is where my solution needs to be. And so the solution to x being greater than negative 6 and x being less than 1 is this region between negative 6 and negative 1. As an interval, it's round parentheses, negative 6 comma positive 1, round parentheses because I don't have the or equal to. A better way to write this, although this is a correct description of the solution to this, is an inequality with the x written between the two numbers. So when I want x to be bigger than negative 6 and less than 1, I write an x between a negative 6 and a 1, and I do two less than signs. This would be the nicer way to write this. Because the second inequality, you see x is less than 1. That inequality that says negative 6 is less than x, if I switch the order, put the x on the left side, the negative 6 on the right side, to keep it having the same meaning, I keep the open end pointing towards the x, the closed end pointing towards the negative 6. And negative 6 is less than x, which that says x is greater than negative 6. So the solution, the nice form of the solution to this scenario is x is between negative 6 and 1. I could write it as an interval. I could write it with less than. It's better writing it with less than. The second scenario, the first inequality would give me x is less than negative 6. The second inequality would give me x is greater than 1. Let me graph those again. For x less than negative 6, I have to locate negative 6 on my number line, draw an open circle because I don't have an or equal to. My graph goes to the left for a less than. So that's the graph of x is less than negative 6. For the graph of x is greater than 1, open circle on 1, make my graph arrow go off to the right. And this is the kind where there's no solution because there's no numbers that are simultaneously less than 6 and greater than 1. And I can see that because the numbers that satisfy both inequalities simultaneously would be where the graphs overlap. So this is where he crossed out this. And so this doesn't yield a solution. This doesn't add anything to the solution because there's no numbers that make those true. So the whole answer to this problem, the numbers that make the x squared plus 5x minus 6 less than 0 are any numbers between negative 6 and 1. The nice thing is almost every single problem we do has exactly this scenario. I'm going to factor, I'm going to create two scenarios. With a less than, my scenarios will have opposite signs. One will have one greater than and one less than and one greater than. If it's a greater than sign, I'll have two greater than signs, two less than signs. And I'll just sketch out my solutions and write an answer. So same deal. First step is to factor. Easy factoring for all these problems. There's no bottoms up factoring. This factors into x minus 3 times x minus 1 is less than 0. Now I'm going to create my two scenarios. The two scenarios, because I'm multiplying these two numbers and getting a negative number, a number less than 0, is they have to have opposite signs. One scenario that would work is that x minus 3, the first factor, is positive, and x minus 1, the second factor, is negative. The second scenario that would work is if the first factor was negative, that's x minus 3 was less than 0, and the second factor was positive, that is x minus 1 is greater than 0. I'll solve these, graph them, and figure out what my solution is. This x is minus 3 is greater than 0. If you add 3 to both sides, you get x is greater than 3. For the x minus 1 less than 0, if you add 1 to both sides, you get x is less than 1. If I graph these, the first situation is x is greater than 3. So I find 3 on my number line, draw an arrow going to the right with an open circle because I don't have the or equal to, greater than is to the right. And then for the x is less than 1, open circle on x, graph going off to the left. Because I'm looking for where both of these are simultaneously true, I'm looking for where the graphs overlap. Since the graphs don't overlap, this scenario doesn't give a solution. There is no number that's simultaneously less than 1 and greater than 3. In the second scenario, where the first one is negative and the second one is positive, if I add 3, I get x is less than 3. To this one, if I add 1, I get x is greater than 1. Let me graph those. I need to put 1 and 3 on my number line. For x less than 3, I get an open circle on 3, a graph going off to the left. For x greater than 1, I get an open circle on 1, a graph going off to the right for greater than. I look for where the lines are both exist, and that's between 1 and 3. A solution for this scenario would be the open interval from 1 comma 3, round parentheses because I don't have an or equal to. The better way to write that, or the way I'd prefer you to write that, is 1 is less than x is less than 3. That says, that one over there says x is less than 3. This one says 1 is x less than x, which means x is greater than 1. And because that doesn't have a solution, this solution is the whole solution to the problem. So the answer to problem 4 is going to be 1 is less than x is less than 3. If you wrote the open interval from 1 to 3, I'd live with it, but I prefer that. Less thans, I think, are the easier scenarios. In the video, he did greater than first, then less than second. I'm doing less than first and greater than second, because for me, the less thans are easier. But maybe you'll find the less thans aren't easier. 6, same deal. The or equal to part of the inequality, that's just going to make me have solid dots, square rectangles as opposed to square brackets as opposed to parentheses, round parentheses, but the problem's going to be set up the same way. So I'm going to factor. This factors into x plus 4 times x minus 2 is less than or equal to 0. I'm going to create my two scenarios. Same sort of scenarios because of the less than. The or equal to part doesn't impact the scenarios too terribly much. So to multiply these two factors and get a negative, they have to have opposite signs. So the scenarios would be the x plus 4 factor is less than or equal to 0, while the x minus 2 factor is greater than or equal to 0. The alternative would be the x plus 4 factor is greater than or equal to 0, and the x minus 2 factor is less than or equal to 0. It doesn't matter which side of this vertical line you write these on. We need two scenarios, one with a less than with the x plus 4 and a greater than, both having opposites, one less than, one greater than, one greater than, one less than. So one with an x plus 4 less than 0, one with an x plus 4 greater than 0. Solve these. The first one, the x plus 4 less than or equal to 0, solves to x is less than or equal to negative 4. The x minus 2 is greater than or equal to 0, solves to x is greater than or equal to 2. To figure out what solution this gives me, I graph x is less than or equal to negative 4. I get a solid dot on negative 4, less than, I make an arrow going to the left. For the x is greater than or equal to 2, solid dot on the 2, arrow going off to the right. This gives no solution because the graphs don't overlap. This is I think the number lines would have been nice if he put it in the video, but he didn't. And if you can do this without the number line, that's preferred. When I do this by myself, I don't draw the number lines, but I thought this might help you in case you didn't notice how to dig the solutions out from his logical thoughts. This set of inequalities, the first one solves to x is greater than or equal to negative 4. The second one solves to x is less than or equal to 2. If I graph these, I need to have negative 4 and positive 2 on the number line. The x is greater than or equal to negative 4. I get a closed circle on the negative 4, a line going off to the right. The x less than or equal to 2, I get a closed circle on the 2, a line going off to the left for less than. And where the shadings, where the lines overlap, is this region between negative 2 and 4. A correct way to write this answer to this scenario is any number between negative 4 and 2, including negative 4 and positive 2. The better way to write that for me is to say negative 4 is less than or equal to x is less than or equal to 2. Because only the second scenario gave me an answer and the first scenario didn't give me an answer, the second scenario is the entire answer. And the answer to this problem is going to be any number between negative 4 and 2, including the negative 4 and the 2. So probably have one more lesson. I might actually get to the greater thans, I'm not sure. Yes, one last less than. Less thans all kind of work the same way, whether they're fractions or squares. The answers will all kind of look the same. If you look at my three answers that I came up with so far, x in between negative 6 and 1, x in between 1 and 3, x in between negative 4 and positive 2. What each of these problems had in common is they're going to be a less than. They were a less than to start. My answer had an x between two numbers. It's probably going to be the case here. For all the problems we do, that's going to work that way. I can make problems that don't work that way, but I didn't try to make any complicated problems in my instructions on how to present this material. I was told to present it lightly or cover it lightly, and to me that meant don't get into any of the really, really grungy details that could make it really horrible. So first step, factor. Second step, two scenarios. And again, the scenarios are going to have opposite signs because of the less than or equal to. So scenario 1 is going to be the first x plus 1 is I can make it greater than or less than 0. It doesn't matter which I do first. Let me do the greater than or equal to 0. And then, because I want less than 0, the x minus 5 less than it in this scenario needs to have the opposite direction, so it would have to have a less than. The second scenario would be the x plus 1 would actually be less than or equal to 0. For the whole product to be less than or equal to 0, this x minus 5 would have to have the opposite sign, and that would be x minus 5 is greater than or equal to 0. Solve these out now. This first scenario, you get x is greater than or equal to negative 1, and x is less than or equal to 5. Let me graph those out. I'll find negative 1, positive 5 on my number lines. The x greater than or equal to negative 1, I get a solid circle on the negative 1, go off to the right. X less than or equal to 5, solid circle on the 5, go off to the left. The solution is where I have both lines, and that's going to be in between negative 1 and 5. Square brackets because of the or equal to. Better way to write this is negative 1 is less than or equal to x is less than or equal to 5. The second scenario is going to be one where I get no solution. The x plus 1 less than or equal to 0 simplifies to x less than or equal to negative 1. The x minus 5 greater than or equal to 0 simplifies to x greater than or equal to 5. When I graph these, I find negative 1 and 5 on my x-axis, or on my number line. Less than or equal to negative 1, solid circle on the negative 1. Make my arrow go to the left for the less than. X greater than or equal to 5, solid circle on the 5, go to the right for the greater than. And because there's no overlapping, this scenario doesn't give a solution, which means the answer to the first scenario is my answer. When we get greater thans, each of the scenarios is going to have a solution. And when I go to write my answer, I'm going to write each scenario's answer with an or, the word or between the scenario answers. So that's the last less than in the non-fraction problems. Getting into greater thans work similarly. I'm going to factor and create two scenarios. But the scenarios were going to be different. The scenarios need to have both positive or both negatives, because to multiply two factors and get a positive or something greater than 0, I have to have both with the same sign, either both negative or both positive. So when I create my scenarios in problem 10, after I factored and got x plus 6 times x minus 1 is greater than 0, my scenarios are going to be this. Either both of these are positive, that's x plus 6 and x minus 1 is greater than 0, or they're both negative, that is x plus 6 is less than 0 and x minus 1 is less than 0. So the scenarios are different with greater thans. With less thans, each scenario has one greater than, one less than. With greater thans, either both greater than, both less than. Solve these now and graph them to get the solution to each scenario. The first x greater than 6, if I move the 6 over, I get x is greater than negative 6. The x minus 1 greater than 0, I get x greater than 1. I'm going to draw a negative 6 and a 1 on a number line. Open circle on the negative 6 and go off to the right because it's a greater than. For the 1, open circle on the 1 and go off to the right because it's a greater than. My solution is where where I have two lines, and I have two lines or two graphs any place to the right of 1. As an interval, that would be from 1 to infinity, round bracket because of the open circle on the top one. The way I would write this is just x is greater than 1. They're both correct answers, but for both of these statements to be true, x has to be bigger than 1 because that's where you get the double shading. Or logically, for a number to be bigger than negative 6 and negative 1, it has to be bigger than 1. Second scenario will work similarly. I'll solve the first one and get x is less than negative 6. The second one gives me x is less than 1. I graph them both. Draw a negative 6 and a positive 1 on the number line. Both the inequalities are less than, so above the negative 6 and above the 1s, I write open circles for the not or equal to, make my shading go to the left. And the region where I have both graphs is the region between negative infinity and negative 6. So anything less than negative 6. And the solution to that in that region is x is less than negative 6. My answer to the entire problem would take the unique solutions to each scenario and put the word or between. And so I snuck that word or in. So the answer to this is any number x greater than 1 or less than negative 6. So in the greater than problems, each scenario is going to get a solution, which I'm going to write with an inequality. And I'll put the word or between the two, each scenario solution. And that'll be my final answer. 12 is another greater than. I'm going to factor, create two scenarios. So I'm going to go, this factors into x minus 1 times x minus 3 is greater than 0. My two scenarios are they're either both going to be positive. That's x minus 1 is greater than 0 and x minus 3 is greater than 0 because I want their product to be positive. So that means they're either both positive or they're both negative, because if you multiply two negatives, you get a positive. So those are my two scenarios. Again, because it's a greater than, the scenarios have both greater thans or both less thans. If it's a less than, you have opposite signs. Going to the first scenario here, I get x is greater than 1 and x is greater than 3. Draw 1 and 3 on a number line. X is greater than 1 is anything to the right of 1. X is greater than 3 is anything to the right of 3. I'm looking for where I have both graphs. I have both graphs between 3 and infinity, or anything bigger than 3. Round bracket on the 3 because no are equal to. And I'd say the solution to this scenario is x is greater than 3. Or I could write 3 to infinity. For the second scenario, I solve this and get x is less than 1. And I solve this and get x is less than 3. Draw 1 and 3 on my number line. X is less than 1, I go to the left of 1. X is less than 3, I go to the left of 3. Again, I'm looking for where my shadings, where I have both lines. That's anything between negative infinity and 1. Or similarly, I would say this region, I would define that region as x is less than 1. Because each region produces a solution, when I go to write my answer, I write the solution that each region generates separated by an or sign. And every greater than that we're going to have, the answer is going to look like that. So if you look at all your less than answers for all the problems we do in this section, all the less thans are going to have an x between two numbers. All the greater thans are going to have two different inequalities, one greater than, one less than, with the word or between them. And I could definitely make that not happen with tweaking the problems in an evil way, but I didn't do that for any of the problems. 14 is a greater than or equal to. Factor this, I get x plus 4 times x minus 2 is greater than or equal to 0. My two scenarios, they have to have the same signs because I'm going for a greater than. The or equal to part doesn't impact the signs having to either be both positive or both negative. Because I want the product to be positive, they're either both positive or they're both negative. Solve each. Each one's going to give a solution. This, I'm going to solve this and get x is greater than or equal to negative 4. And x is greater than or equal to 2. If I graph them both, and maybe you can do this without graphing, which is better. Solid circle on the negative 4 and go to the right. Solid circle on the 2 and go to the right for the greater than. The regions where these shadings overlap is between 2 and infinity. Closed circle, so I get a solid dot. And I would write this as just x is greater than 2. That blue region is where they overlap. The solution to this is going to be x is greater than or equal to 2. The next scenario, I get x less than or equal to negative 4 and x less than or equal to 2. Find negative 4 and 2 on my number line. Less than or equal to means I go to the left. So x less than or equal to negative 4 looks like that. X less than or equal to 2 looks like that. The regions where I get double lines is this region between negative infinity, which is the far edge of the left axis, and negative 4. Or just that gold region, which is x is less than or equal to negative 4. And that's how I'm going to write my answer. I'm going to define this region as x is less than or equal to negative 4. Put the two answers from each scenario with the word or between, and that's the answer to that problem. I think 16 is the last square one. And then I get into fractions. Fractions aren't going to be any different. Factor 16, it factors into x plus 1 times x minus 5 is greater than or equal to 0. Create my two scenarios because I want a positive answer. Both factors are either positive or both factors are either negative. I'm not going to have one of each sign. To have one of each sign, it'd have to be a less than. So I set up my two scenarios, one with them both positive, the other with them both negative. I'll solve this one. I get x is greater than or equal to -1, and x is greater than or equal to 5. Find -1 and 5 on my number line. Greater than or equal to -1 is to the right of -1. Greater than or equal to 5 is to the right of 5. Solid circles because they are equal to. And the region is going to be that just from, I'm just going to call that x is greater than or equal to 5. That's the region where both graphs exist. Put the word or down because my greater thans generally have that or. This scenario, I get x is less than or equal to -1 and x is less than or equal to 5. Graph the x is less than or equal to -1, solid circle off to the left. X less than or equal to 5, solid circle off to the left. The graphs overlap in this region, the orange region, which is x less than or equal to -1. And I'm going to write that solution in my answer. And that would be the answer I would show for number 16. So that's the end of the square problems or the quadratic problems. The rest of the problems are fractions. It turns out that they're identical. The problems all have a less than or a greater than, and they're compared to 0, and that's a perfect situation. And these problems, although they look completely different, logically they're going to solve the same way. Because for a fraction in 18 to be negative, either I'm dividing a positive in the numerator and a negative in the denominator, because a positive divided by a negative is a negative, or I have a negative in the numerator and a positive in the denominator because a negative divided by a positive is a negative. I can't have both the numerator and the denominator positive because if I divide two positives, I get a positive. And I can't have the numerator and the denominator negative because if I divide two negatives, I get a positive. There's no factoring in the fraction ones. I'm just going to create two scenarios, and my scenario is going to compare the numerator to 0 and the denominator to 0. Because it's a less than, the comparisons need to have opposite signs. So I'm going to create two scenarios I don't have to factor here. So my two scenarios are going to be x minus 2 is less than 0 and x minus 9 is greater than 0, meaning I have one negative and one positive. Or x minus 2 is greater than 0 and x minus 9 is less than 0, one positive and one negative again. It's not going to come up in any of these problems, but a fraction, you can't get a 0 in the denominator. 9 would not be in the domain of my answer because if you put 9 in, you get undefined. X is not allowed to be 9. It's not going to be an issue at all, but it would be something in a more complex problem that you might have to consider numbers outside the domain of the fraction, but they won't come up in our problems at all. So I'll solve these just the same way. The first one I get x is less than 2 and x is greater than 9. Find 2 and 9 on a number line. X is less than 2, left from 2, x is greater than 9, to the right of 9. This one doesn't give any part of my answer because there is no number or aren't any numbers that are less than 2 and greater than 9. Second scenario, I get x is greater than 2 and x is less than 9. Draw 2 and 9 on my number line. X greater than 2, open circle to the right of 2. X less than 9, open circle on 9 and go to the left. The overlapping region is between 2 and 9. That's this as an interval. Round brackets because we don't have the or equal to. This is the only answer. I'm going to write it with the double less than's and the x between 2 and 9. The answer has to be x has to be between 2 and 9. And the way I'll show that is 2 is less than x is less than 9. So just like with the quadratics, The less than, we had one part that didn't give a solution, the other part did give a solution. It's the same way for all the fractions that I have, because I didn't make any problems that were, bizarre out of any usual kind of form. 20, same deal. I have a fraction less than 0. Need to create my two scenarios. My two scenarios would be the numerator being positive while the denominator is negative. That's a positive divided by a negative, and that would give me a negative. The other scenario would be the numerator being negative and the denominator being positive. That would still give a solution of x plus 2 over x minus 2 as a negative number. Solving this one, I get x is greater than negative 2 and x is less than 4. To do that, I find negative 2 and 4 on a number line, greater than negative 2, open circle, go to the right, less than 4, open circle, go to the left. This means x has to be between negative 2 and 4. I'm going to write that as negative 2 is less than x is less than 4. The next one's not going to give an answer. This is going to wind up being the whole answer, but you don't know that for sure, I guess, until you do it. This second scenario, I get x is less than negative 2 and x is greater than 4. Plot negative 2 and 4 on a number line, less than negative 2, an arrow to the left of negative 2, greater than 4 to the right of 4. No solution to that because there's no overlapping between the graphs. The no overlapping between the graph means I don't add anything to my solution, and the solution to this first scenario that I drew is the whole solution. 3 more problems. Now we have a greater than. With the greater than, I need to have both positive or both negative. So in 22, I'm going to go either x minus 1 is greater than 0 and x minus 5 is greater than 0 for one scenario. The second scenario would be x minus 1 is less than 0 and x minus 5 is less than 0. Greater thans usually both work, and you usually wind up writing the answer to each with an or between. This scenario, the first scenario, I have x is greater than 1 and x is greater than 5. I find 1 and 5 on my number line. X is greater than 1 is going to the right of 1. X is greater than 5 is going to the right of 5. The overlapping region is that region that's the x is greater than 5 region. So this first scenario, the overlapping part of the graph is in the x greater than 5 part. That's going to be the solution to the first scenario. Second scenario, I get x is less than 1 and x is less than 5. Draw my 1 and my 5 on my number line. X is less than 1, I go to the left of 1. X is less than 5, I go to the left of 5. The overlapping region is the x is less than 1 part, so the solution to that region is going to be x is less than 1. Both regions have solutions. I write the solutions next to each other with the word or in my final answer. So I'm going to get x is greater than 5 or x is less than 1. 24, another greater than. I need both my answers to be positive or both might be negative. So I'm going to go either x plus 2 is greater than 0 and x plus 6 is greater than 0, or x plus 2 is less than 0 and x plus 6 is less than 0. This gives me x is greater than negative 2 and x is greater than negative 6. Find negative 6 and negative 2 on my number line. Open circle to the right for greater than. Open circle for the right to greater than. The region here where I get both is x is greater than negative 2. So that's part of my answer. This next region, I get x is less than negative 2 or x is less than negative 6. Find negative 2 and negative 6 on my number line. Go to the left for less than negative 2. Go to the left for less than negative 6. The region where I have overlapping is the x is less than negative 6 region. So the answer to this is going to be x is greater than negative 2 or x is less than negative 6. One more problem, it isn't anything new. I just tossed a less than at the end, and I'm not even sure why I did that, but it's here. It's going to take a second to do. It's a fraction with a less than, no factoring needed. I create the two scenarios. Because it's a less than, my scenarios need to have opposite signs. So that would be x plus 5 greater than 0 and x plus 1 less than 0, or x minus 5 less than 0 and x plus 1 greater than 0. I need them to have opposite signs because it's a less than. First scenario here, I get x is less than 5 and x is greater than 5 and x is less than -1. This is going to be a no solution because x is greater than 5 is to the right of 5. X is less than -1 is to the left of -1. That gives no solution. And in less thans, that for us, it happened in every less than. The next one, I get x is less than 5 and x is greater than -1. So I draw -1 and 5. X is less than 5 to the left of 5. X is greater than -1 to the right of -1. I get the region here, where I have the region's going to be between -1 and 5, where I have both lines, round brackets because open circles. And I'm going to write my answer. I'm going to write that region with an inequality. -1 is less than x is less than 5. So that's the whole section and the end of the chapter. So what you need to do is perfect this section the best you can, and then study a little bit and take the review like it's a test. So don't watch my video before you do the review. Do the study, do the review like it's a test. Grade yourself, and more or less there's answers and solutions worked out. And then after you've gone through the review without watching the video, then watch me do the review video just to kind of check yourself to make sure that everything you did was kind of in line with what you should do. But you absolutely shouldn't just turn the review video on and just watch it without trying to take the review like a test. The review is the best thing to prepare you for the test because my tests are always like the review. Usually they're a little bit shorter, and usually they're in a different order. So problem 6 on the review might be problem 2 on the test with different numbers, essentially. Okay, I'll have to shut it down.